Continuing in Chapter 2, we're going to cover measures of central tendency. This is Section 2.3. A lot of this information you probably heard as well, and this section goes by pretty quick. So average is called the mean, and it's the sum of all the data entries divided by the number of entries. You've all found the average before. We do determine the population mean and the sample mean distinguished differently. We use this Greek letter, which is mu, and then we also use the x with the bar over it, and literally we call that x bar. X bar represents the sample mean, mu represents the population mean. Example number 1, the weights in pounds for a sample of adults before starting a weight loss study is listed below. What is the mean weight of the adults? So we have these values. We're going to sum up these x values. We're going to divide it by the number that there are, which is n. This is a sample, so that means that this is x bar, representing my sample mean. So if I add 274, 235, 223, 268, 290, 285, and 235, and divide it by 1, 2, 3, 4, 5, 6, 7, because there are 7 adults, I get roughly 1810 divided by 7, which is approximately 258.6 pounds. And that's this sample mean. All right. The next word that you probably have heard about in definition is the median. It is the value that lies in the middle of the data set, provided the data set is ordered. It does have to be in order, so make sure that when you're doing this, you are putting things in order. Odd number of entries says the median is the middle. Even number of entries says that the median is the mean or the average of the two middle sums. So if I find the median of the weights listed above, I'm going to put them in order. That would be 223 first, 235 next, and actually 235 is twice, since our 235, two values of 235. Then we have 268, 274, 285, and 290. This is 7. There are 7 items, so that means that halfway is going to be in the middle. So here's 1, 2, 3 on each side, putting 268 in the middle. So my median is equal to 268. In the previous example, the adult weighing 285 pounds decides not to participate in the study. What is the median weight of the remaining adults? So again, if we put them in order, not counting the 285 pound person, now I have 6 entries, so that makes these 2 in the middle, the 2 middle entries. So this time, my median has to be averaged. So I'm going to take, it's going to be averaged. So I'm going to take the 235 plus the 268, divide them by 2, and I'll get 251.5 pounds. Odd numbers, it's directly in the center. Even number of entries, we do have to find the average. The last word that you're probably familiar with when we talk about a lot of things in statistics is the word mode. So mean, median, and mode. Mode is the data entry that has the greatest frequency, so it occurs most often. If no entry is repeated, the data set has no mode. If two entries occur with the same greatest frequency, then it is called bimodal. So looking at the data set above, again, if we looked and rewrite them just so you can see them again, 235, or 223, 235, 235, 268, 274, 285, and 290. The one that occurs twice or more often than the others, mode, is 235. So my mode in this case is the 235. It is not bimodal because there's no entries twice, no secondary entry. Okay. Here is the points scored for a Super Bowl wins in the NFL season. Find the mean, median, and mode of each one of those. Be sure to show all of your work. I do expect you to use a calculator, but I also need to see how you found your answers. So much like what I did to find the mean, I listed the numbers divided by whatever I divided by. That's the kind of work I need to see. For median, I need to see the numbers listed in order so that you can get that middle number. For mode, it would be the one that occurs most often. So when it says show all work, make sure you are indeed showing all of your steps. Use a calculator, absolutely, to help you with the arithmetic, but I still need to see what you're putting in your calculator, how you're getting your answer. All right, the table below shows the average sample age of students in the class. Find the mean, median, and mode of their ages. Are there any outliers? We're going to start talking about what an outlier is, and then which measure of central tendency best describes a typical entry for this data. All right, well, it's a sample. So X bar says to add up all of the numbers and divide by the number that they have. So that would be to add up these 20, because addition is multiplication repetitive. There are 6 students that are 20 years old. There are 4 students who are 21. There are 3 students who are 22. There are 4 students who are 24. There are 2 students who are 24. I think I said that backwards. And there's a person who is 65. Total, there are 1, 2, 3, 4, 5, 6, 7, 14, 20 students in the class. If I multiply and add, then I end up with my X bar equaling to 475 divided by 20, which is 23.75. If you don't like the way this is written out, of course you can always do 20 plus 20 plus 20 plus 20 plus 20 plus 20 for the 6, then 21 plus 21 plus 21 plus 21 plus, and so on and so on and so on. This is just a simplified way of writing it. But if you don't like that way, then you don't have to use it. All right. So there is my mean. My median, well, these numbers are in order, so that's good because there's 20 of them. Then there's going to have the 2 in the center. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be put 21 and 22 in the center. So my median is going to be 21 plus 22 divided by 2, which is equal to 21.5. My mode is the one that occurs most often. If we use this format up here to find the mean, then you would know that the mode is 20. So then it says, which measure of central tendency best describes a typical data entry point? So if we look at what might be typical, well, one of the things that we have to look at is the fact that this person who is 65 is outside the range of everybody else. So in this case, 65 is an outlier. It falls outside the average, the things that we're looking for. So 65 is way above my average, it's way above my median, and it's way above my mode. So that makes it an outlier. The mode of 20 may not be your typical. So typical age may not be 20. Just because coincidentally most of the students were 20, that may not be the typical age. It may be more that this median actually may be a better fit for the data. So the median may be the best fit for the data, the one that describes it the best. The next is what's called a weighted mean. And a weighted mean is an entry is a data set where the entries have varying weights to them. So we're going to have to sum all these up, divided by the weight, where W is the weight of each one of the entries. This is very typically found when we talk about GPA, because an A is worth more than a B is worth more than a C is worth more than a D, and of course an F is not worth any point value when we talk about your GPA. So A is typically 4.0, B is a 3, C would be a 2, D is 1, and again F is 0. So determine your grade point average. So we're going to change the letter grades to their value. So a C is worth 2 points, a D is worth 1 point, an A is worth 4 points, C is worth 2, B is worth 3. So the weight of the grade also is affected by the number of credit hours. So we're going to multiply 2 times 3, 2 times 4, 1 times 1, 4 times 3, 2 times 2, and 3 times 3 to get us the value points for your GPA. Not your GPA, but the value of your grades, those points. So 6, 8, 1, 12, 4, 9. It's a good thing you made a D in a course that's only 1 credit hour, because it didn't hurt you as much. It would be nice to make A's in 4 credit hours because it gives you the most points. At any rate, if I add this up, I end up with 40. It says that I'm going to take 40. So my average GPA is going to take the 40, and I'm going to have to divide by the number of credit hours that I have. In this case, that means I'm going to add up this column. If I add this column up, I get 16. So the credit hours is 16. If I do 40 divided by 16, my GPA is 2.5. And that is how we determine GPA all the time. So if you didn't know that, now you can go back and determine your GPA. Here's another example for you to follow, to try on your own. And then we go on to the mean of a frequency distribution. Remember, we talked about frequency distribution in an earlier section. So to do that, my x bar is equal to the sum of my x times my frequency divided by n. and n is equal to the sum of all the frequencies, where x and f are the midpoints and frequencies of a class, respectively. So to find the mean of a frequency distribution, the frequency distribution shows the out-of-pocket expenses out-of-pocket prescription medicine for 30 U.S. adults in a recent year. Use the frequency distribution to estimate the mean expense. Using the sample mean formula, the mean expense is $285.50. Compare this with the estimated mean. So what that means is we're going to find x bar, and we're going to use the formula sum of x f divided by n. And so here's the work done for you. Here is the midpoint. Remember, we have to use the midpoint. That's your x value. The frequency is how often it occurs. The frequency is how often it occurs. XF. Now remember, mathematically, if you see two letters next to each other, that by default means to multiply. So we're going to take x times f. 172 times 3 is 517.5. 208 times 2 is 417, and so on and so on and so on. So this 8,651 really is the sum of the column XF. This 30 really is the sum of the frequency. So now I just have to use those two numbers, 8,631 divided by 30, and that's going to give me $287.70. Right. Then it says, the second part of this question says that the sample mean formula for the mean expense is. So before we put it in a frequency table, before we did anything about it, we actually took the exact amounts. Remember that this frequency, this midpoint, is a class. So there's a number above it and a number below it, but we use the midpoint. The actual mean for the actual data is equal to 285.5. So you can see that by doing this mean of a frequency distribution, by sort of doing the average in the class, by using the midpoint, it gets a pretty close number. So this is pretty close to the same. So it's not a bad way of doing it. If you had to really say something specific, then this 285 is a much better representation because it is exact. So this one is better because this is exact. But it's pretty close. And sometimes easier to use, or especially if you don't have the original data. If all you know is this frequency table, but you don't have the initial data, then you're not going to be able to do anything other than find the mean of this distribution. So your conclusions is, again, they're close, but 285.50 is the better. It's the most accurate value, or most accurate mean, or average. All right. We're almost done with this section. So the next thing we do is we take a look at how things are distributed in relationship to a curve, histogram in this case, and the mean, median, and mode. And so the symmetric distribution says a vertical line can be drawn through the middle of the graph of distribution, and the resulting halves are approximately mirror images. So if I were to draw a line straight down this center, you can see where these are almost mirror images, and that's because the mean, the median, and the mode are all similar, close to the same. In this case, it looks like exactly the same, but that's because it's exactly a mirror image here. They'll be close, but not necessarily exactly the same. A uniform distribution is where everything seems to be in a literally the same amount all the time. Again, my mean, my median, and the mode can be the same, but at the same time, there's no variation in the way the shape of this goes. So since there's no variation, this is called uniform. And then we have these last two graphs. The top one is skewed left. The bottom one we call skewed right. Skewed left is negatively skewed. It says the tail of the graph elongates more to the left. So that means that as we have here, we have a lot more to the left versus this one which drops off. So this is like the up part of a roller coaster versus the immediate downfall. So this one is skewed left, where this one is skewed right, because this data goes back here to the right. It sort of tapers off to the right. So it tapers to the right. And that will wrap up section 3. Much shorter than the previous section. Thank you for being here.